Step 7. Make a decision to either reject the null hypothesis or fail to reject the null hypothesis. Now, reject the null hypothesis. What this means is I have enough evidence to prove that the null hypothesis is wrong, where we cannot accept the null hypothesis. Now, fail to reject the null hypothesis is that I don't have enough evidence to prove that the null hypothesis is wrong. Now, hint, think of the null hypothesis as a working assumption that you may or may not believe. Now, making a decision to either reject the null hypothesis or fail to reject the null hypothesis. So, let's first discuss the p-value. Okay, so the decision criteria for the p-value method. If the p-value is less than or equal to alpha, then we reject the null hypothesis. Another way of saying that is, if the p is low, then the null must go. And if the p-value is greater than the significance level, then we fail to reject the null hypothesis. Okay, and so the way to do that is, again, is to look at our particular graph over here to the right. So let's say that this shaded area represents the p-value, and here is our test statistic. Okay, so first that's given. So let's say that alpha is given as a significant level of 0.05. Okay, and let's just say that we get the following p-value. Let's say that the p-value here, or the area that we end up getting for a p-value is, let's say, 0.021. Okay, let's say that is the p-value, and the test statistic, since if you were dealing with a proportion, would be whatever the value may be for the test statistic. Okay, so what we'd want to do is we would need to compare the following. We want to compare the p-value versus the significant level. So let's say that our p-value that I had just written over there is 0.021. And then the significant level which was given is 0.05. Okay, so when we compare that, we can see that the p-value is less than that. If this value is less than that, then we would say that we would reject the null hypothesis. Okay, now let's say that we had a different scenario. Let's say that our scenario would then be a p-value that is greater than that. Okay, so let's say that we have a different p-value. So let's use a different example here. And let's just make up a p-value here. So if we wanted to compare a different p-value versus alpha, and let's use the same alpha. Let's say that we have a p-value of 0.413, and we're looking at the significant level of 0.05. Well, that tells us that the p-value is greater than that. And if that is the case, then we would say fail to reject the null hypothesis. So those are the two scenarios. Okay, if the p-value is less than or equal to alpha, then we reject the null. If the p-value is greater than alpha, then we fail to reject the null. Okay, now let's take a look at what this would mean for the critical value method, or we also call this the traditional method. Okay, so in this case here, it says if the test statistic is in the critical region, you reject the null. If the test statistic is not in the critical region, then we fail to reject the null. Okay, let's say that we have a test statistic. Okay, now a test statistic can also be a z-score. Okay, so let's say that we have the test statistic, and let's say in this scenario z is equal to 1.25. Okay, so if we take a look at the first scenario, okay, we would say that in this case here, the test statistic of z is equal to 1.25 is not in the critical region. Okay, so you can see here that it's to the left of the critical value, and the critical region is what's shaded there, because the critical region is what is shaded. So again, here is our critical region. This is our critical region that's shaded here. Okay? And so that is to the right of the critical value in this scenario. Now, again, looking at this scenario, if the test statistic is in the critical region, we reject the null. But this test statistic is not in the critical region, so we would say that we would fail to reject the null. Okay, so that would be one scenario. Okay, let's say that we had a different test statistic. Okay, let's say that we had a test statistic that was over here. And that test statistic was z, which is equal to 1.81. So we would say that the test statistic of z, which is equal to 1.81, is in the critical region. So since it is in the critical region, we would say that we would reject the null hypothesis. So those are the two scenarios.